I'm Mrs. Mattis, and I want to talk to you about the reason for the seasons. First of all, I'd like to start off and clear up a misconception that many people have about why we have 4 seasons here in Illinois. If I were to go out on the street and talk to a number of people, the most common answer that I would get for the reason for the seasons would be the distance that the Earth is from the sun. Most people think that the Earth is closer to the sun in the summertime, and that's why it's hot, and farther away in the wintertime. That's why it's cold. And that is not correct at all. As you can see from this picture here, when it is wintertime in the northern hemisphere, the Earth is actually 147 million kilometers away from the sun, and in the summertime, over here, the Earth is 152 million kilometers away. So as you can see, in the summertime, the Earth is farther away from the sun than it is in the wintertime in the northern hemisphere. So I'll come back to this side here, but I just wanted to start with that common misconception that people in the northern hemisphere have. So then, what actually causes the seasons? Okay, there are two main reasons for the seasons, and they both work together. One of them is the tilt of the Earth, and the other one is the angle at which sunlight hits the Earth. So if we take a look at this picture here, one of the things that we need to take a look at is this imaginary line that runs from the North Pole to the South Pole, and that's called the axis. The Earth actually rotates or spins around its axis, and if you think about your fidget spinners and imagine that maybe the fidget spinner was round and the center of the fidget spinner is the axis of the Earth, and so the Earth just rotates around that axis and that axis stays where it is. So the Earth is similar that way. One of the things with the tilt of the Earth, though, is that axis is not straight up and down. The Earth is actually tilted, and it's at a 23.5-degree angle when the northern hemisphere is getting its summer. That angle is facing the sun, or is leaning toward the sun when it's summertime in the northern hemisphere. And that would mean that it would be wintertime in the southern hemisphere, and the Earth is leaning away, or the southern hemisphere is leaning away from the sun. Along with that tilt, though, then comes the angle at which the sunlight hits the Earth. So you can see these lines being drawn here. Those are the rays from the coming off of the sun, and as the Earth is tilted toward the sun, the northern hemisphere here, the northern hemisphere is going to be receiving more direct rays than the southern hemisphere. It's going to have more scattered rays. The equator here is going to be receiving direct rays all the time, and that's why the equator is warm all year round. It doesn't matter where in the revolution the Earth is around the sun, the equator will still be getting those direct rays. So if you think about the direct rays or scattering rays, if I took a water bottle here and have this piece of paper held here straight at the water bottle, and I squirt that piece of paper, you probably can't see that very well, but most of that water was concentrated in one particular area. That was a direct hit with a squirt of the water bottle. That's what happens with the sun's rays as well. If it's getting a direct hit, if the Earth is getting a direct hit from those rays, then that part of the Earth is going to warm up. Now if I turn it over and I tilt this piece of paper and I squirt it, now we see that that water is more spread out on the paper, and that's what happens as the Earth is tilted either toward the sun or away from the sun. Actually, tilt doesn't move. Okay, so if we take a look at another way and we revolve around the sun to the other side, now we see here that the northern hemisphere is pointed away from the sun, or it's leaning away from the sun, and it's not going to be receiving those direct rays. The equator still does get those direct rays, nice direct hit, and then the southern hemisphere is now getting more of those direct hits. As you move away from that equator, there's less direct rays, so the poles, the north and south pole, still are cold, but in the summertime in the southern hemisphere, you're going to see that the sun's rays hit that south pole, and they're down there all the time, and that's when the south pole is going to have 24 hours of daylight, and the north pole is going to have 24 hours of darkness. So the two reasons for the seasons are the tilt of the earth and the angle at which the sunlight hits the earth. And if we take a look back at this side here, we see that the 4 seasons, that the area of the earth that's in this, a little bit above and a little bit below the equator, actually goes through those 4 seasons. They each have their own names. So we have the autumnal equinox, and then the opposite of that is the vernal equinox, and so this is our autumn and our spring. And then as the earth moves around the sun, or revolves, goes around the sun, then we're going to end up with winter solstice. And back up, equinox is when the sun crosses the earth's equator, and there is equal number of day and night hours. And so in the spring and fall we have 12 hours of daylight, 12 hours of darkness. And then as it rotates around, we come to the solstices, and we have our winter solstice over here, which again is the closest to the sun, and we have our summer solstice over here, which is going to be the farthest away from the sun. And a solstice is when the sun reaches its highest or lowest point in the sky, marked by the longest and shortest days. So that is the reason for the season. Again, it has to do with the tilt of the earth and how the earth is receiving the rays from the sun.